Hey everyone, Renee here, back with another devlog for Gravitorium. If you didn't meet me last time, I'm one of two programmers on Gravitorium, upcoming 2D platformer. The demo is out now, it's been out for a couple weeks, and we actually just released a big new update for it, which is why I'm doing this devlog. We added skins to the game, so you can unlock skins several different ways. So one, by just completing the demo normally, and the rest of them by playing our time trial mode and completing it within a certain amount of time. So the better you do, the cooler the skin you can unlock. There's several skins. It's a really big update. It's really cool. I think it provides with players with a lot of motivation to keep getting better at scores in the time trial mode, and I'm really happy with how it turned out. I'll be covering that today, as well as shaders, how I made some of those skins, and yeah, let's just get into it. All right, so we're looking at Unity here. So one of the things that you might remember from last time, if you watched my last devlog, is we were having a bug with the timer text. So when I started time trial mode here, this timer text was sometimes getting unaligned. It would, when I would start the program, it would sometimes start like way down here and be cut in half because it's partly off the screen. But luckily we actually finally managed to fix that. You see, it always stays at its position. It's anchored to the bottom. It turns out that was actually a bug with the previous version of Unity we were on. So it gave me such a huge headache. I thought I was potentially doing something wrong. I was like, isn't this how anchors work? Like, I'm putting it down there. I'm saying anchor yourself to the bottom. What's going on here? After a little digging, I realized it was a known issue with that one that's not well documented, but it was an issue that other people have had with the version of Unity, and I upgraded to another one that other people found had resolved their issues. So that worked out great. So yeah, the reason I didn't upgrade Unity earlier is because generally, especially with smaller projects, you kind of want to stick to the same version of Unity. Upgrading Unity can break certain things in your project with specific packages that might not be compatible with newer versions. So generally, if everything's working pretty much how you want it to in Unity, there's not any new features that you want to use that are available in a newer version, you just stick to the same one. So that was kind of like the last ditch effort for us. I had tried so many different ways of fixing it, and I said, you know what, it's time. Let's go ahead and just upgrade and see how it works. And it worked out great. Haven't seen the bug since. Let's see. So we took a lot of user feedback and made some changes. So like here we have some new control hints. It turned out that a lot of people didn't realize you can actually walk in this game as well. Because before all we had was these rotation hints. So people thought the entire game was supposed to be played only with rotation controls, which is actually pretty doable. You can do that, and it is like an extra added challenge that is very fun. I could beat a few of these levels, actually pretty much all of them, just rotating like this. But adding the walking definitely allows for a lot more nuance, and it is an intended feature. We do want you to use walking as well. So we definitely added some UI hints for that. There are controller hints as well, actually. If I plug in one of my controllers here, I can show you. There you go. It switches, as well as the rotation, if you notice. They both switch to whatever is the most recently active control type. So yeah, those are the main minor changes we made due to feedback and bug fixes. But let's get into the big change here, which is the skins, right? So here we go. There are 6 total skins now. The first one is unlocked by default. That's just the default skin, obviously. That's Huey's original color, Huey, the name of our alien here. And the second one you can unlock is the checkerboard, which is unlocked by beating the game normally. You just beat the demo through the normal story progression. At the end of it, you get the checkerboard, which is not only a reward for beating the game, but also kind of telling you, hey, let's get into the time trial mode. It's supposed to look like a checkered flag almost, right? So it's fun to jump into time trial right after with using the checkerboard skin. I'll show you what it looks like in game actually. So if I hop into time trial here, Boom, I got the checkerboard going on. Nice little change there. So let me go over the other skins as well. So we've got the bronze, which is finished time trial in 6 minutes or less. Silver, 5 minutes or less. And gold, 4 minutes or less. And finally, diamond here. So diamond, let me make this a little bigger so you can see. This one actually has some particle effects. I wanted to make this, it's got some like sparkles going on, right? And I'll show you what it looks like in game in a second. I wanted to make this kind of like the elusive skin. So far, actually nobody on Steam has gotten a sub 3 minute. Now, I know that it's possible to get sub 3 minutes because I've done it myself. I just haven't posted that score to the Steam leaderboard because it feels a little weird setting like a really high score on my own game so early on. I kind of want people to get there organically and not steal the limelight as one of the developers. It just feels a little strange. So I'll open up Steam actually real quick so I can show you what those leaderboards look like. Last video, I didn't get a chance to show the leaderboards. So let's do that real quick. It should detect now that Steam's open. I have a Steam app ID file in the Unity project, so it should attempt to connect to Steam and show the leaderboards at the moment. Time trial, leaderboard. There we go. So the highest score right now is a 317, 17 seconds and 74 milliseconds off the the 3 minute mark to get that diamond skin. The gold skin is very nice though. Actually, I like how all these skins turned out. I think they all look great. Gold itself looks great. I would be pretty happy if I got gold. But that diamond is there to be, like I said, the elusive one. And for those people that really want to shoot high, get that extra nice skin. And I'll show you what it looks like. I can do a little cheat here in my code where I actually set the skin of the player. This is where I initialize the material, which I'll cover in a second. So one of the main parts of this video is going to be covering the shaders I wrote in order to create those skins. Those skins are not actually new sprite sheets or new art. I literally wrote shaders that replace the specific colors with other colors that I want. And I'll go over that. It's really awesome. It's great for really quick iteration, creating new skins on the fly, as well as the checkerboard actually. Yeah, the checkerboard is also done with a shader. So anyway, I'm going to do a quick little hack here. So player prefs, I covered it briefly in the last video. It's how Unity can store settings for players, and we can save it, and your settings will remain the same across plays. When you turn your game off, come back in. So by default, we set the Huey skin material to default. I'm going to go ahead and actually add a line right before this. I'm going to say diamond. I'm going to set it to diamond so you can see what this diamond skin looks like. And let's go ahead and continue. And there we go. I got that nice diamond skin now. Let me turn on the minimal rotation mode. This mode works better in video setting when frame rates aren't as high and people are watching. It helps with the motion sensitivity sickness. Sometimes people get afflicted with this game just watching it. Players are fun. We have almost no complaints from players. Okay, so if I go here, check this out. There's little particles coming off of it. I can zoom in on that if you want to see actually. Let's get a better view. Got some sparkles coming off. So this is a really nice diamond skin. I gotta say, even the times I unlocked it the way it's supposed to as a dev, like on my own end in Unity, not on the official server obviously, it feels really satisfying to unlock. It's very nice to look at and it was really fun to make. So I hope this will motivate more people to go ahead and try to improve their time trial scores a lot more. Okay. So that's that. So why don't I go over maybe the UI that I did in the skin selection screen. So I pretty much did this. So I built the skins in one day, and then I built this entire UI pretty much on another separate day where I was just really like focused in and I just wanted to get this done. So each one of these buttons is a prefab that I made. It's called the skin button. And basically the components of it, it's got a skin name, default, checkerboard, bronze, silver, etc. It's got the explanation. It's blank on default, but obviously for checkerboard it says beat demo normally, bronze, finish time trial 6 minutes or less. It's got the picture of Huey, which on Huey, I actually drop the material, the same material that is used within the game when you're playing. See, like this one's got the checkerboard material, and like the bronze has the bronze skin material right here. And hopefully you can see that. Actually, let me try. I'm gonna try using the magnification tool here a bit. So here you can see there's this bronze skin material on the bronze skin UI here, UI object, and they all have this check mark as well. That gets switched on and off when you select something. So programmatically, or the setup of this UI is pretty simple, pretty straightforward. Just got 4 different objects on it. Programmatically, it's pretty straightforward as well, actually. Let me see if I can pull up this code here. And hopefully the code is a little more visible than last time. I forgot to zoom in last time. So it should be in menus, skin screen. So I've got references to all the buttons for every screen here. I also have, so in here is where I actually determine if a button is selectable or not. So I set through the inspector, I can set through the inspector, these are the default values which have stayed, but how much time it takes to unlock each one of those skins. And then when at the start of this, when the skin screen is pulled up in the start function here, I determine whether any of these buttons is interactable, whether they meet the criteria for whether the person has unlocked the skin or not, right? So let me zoom in on this actually. There we go. So basically, I check if for the checkerboard skin, if the person has beaten the game, if it even has that key in the player prefs, and if it's equal to 1, which means not only has the key been set, but it's also equal to 1, which is technically equivalent to true. Unity's player prefs actually doesn't have a Boolean type. So you use an integer and set either 0 or 1 to be false or true. And then the bronze skin, so here's what I do. If it has a time trial score, if you have run it at least once, then this player pref gets set. And if the value of that score is less than or equal to the bronze unlock minutes, which is 6 at the moment, times 60, because we're storing this in seconds. So I take 6 times 60 seconds, and if the value within player prefs is less than that, then you unlock it. And it's the same for all these other skins here, right? Silver, gold, diamond, they just go down by 1 minute each. So yeah, and then I have the skin buttons all in one array here. And I determine at the beginning of the skin selection screen which check mark for which button should be set to true, should be set to active, based on what the player prefs has stored for the skin. So we store the skin that is active as a string into player prefs. So if the diamond skin is active, it's going to say diamond. If it's bronze, it's going to say bronze. So one of the first things that happens in the start function is I will set the check mark to the correct button based on the player prefs value. And then when a button is clicked, if it is interactable, right, which means that skin has been unlocked, here is where I actually set the player prefs value of the material. So the skin material, the way we're storing them in the player prefs, actually has the same name format as the label in the button, in the UI button. So I'm just taking directly from the button. When the skin button is clicked, I'm passing in the button on the onClick event. Each button has an onClick event that you can assign a function to. So when it's clicked, it calls this function here, and it passes in the button itself that was clicked. And so what I'm doing is I'm saying player pref set the string of the Huey skin material to the name of the text object skin name within the button, because those names match the player prefs, the way we're storing in player prefs exactly. So it's a really nice, convenient way to do that. Actually, it's pretty efficient. And yeah, so checkerboard, bronze, silver, gold, they all match up exactly with the way we're sorting them in player press. Um, and one other trick I wanted to show you here really quickly is for the diamond skin. As I showed you before, it has these little particle effects on them, right? These little sparkles. So I'm doing that using a custom particle emitter that I created. And let me see if I can open that up here. It is on Huey himself. Oh no, okay. So I didn't put it on Huey. So the thing is, I made actually like a dummy uh, invisible sprite here that carries that actually has the particles on them. They're not directly on the UI element themselves. The thing is, my particle emitter has not yet been made to be compatible with UI objects. And since I was kind of trying to get this update out pretty quickly, I came up with a little hacky solution here. Instead of adding compatibility with UI to my particle emitter, what I did was I added this little dummy sprite that you can't actually see. That's a normal type of sprite, not a UI sprite. And I threw the particle emitter on it, and I just placed it directly on the UI element and made it invisible. As you can see here, I'm sliding the alpha value, and it's just a default alpha value of 0. So that's what I did there. So yeah, once again, I'm really happy with how this turned out. And I think, yeah, I don't need to save anything there. I think we can move on to the next thing. So what I wanted to cover next was how I created those skins, and I did that using Unity shader language, which is HLSL. And I created a couple different shaders. One for the recolors. One for that it just replaces the colors. So I tell it to look up specific colors and replace them. Actually, why don't I just show you instead of talking about it? So like for the bronze skin material here, if I go to the inspector, there's a few different properties here. Color to swap in new color, color to swap 01, new color 01, color swap 02, new color 03. And actually, why don't I start the game and show you how these work. Let's go ahead and start a new game here. I'm gonna skip the cinematic. And so we're on the diamond skin here. So if I zoom in on Huey here, let's go to the diamond skin material. As you'll see, so on the default Huey skin, these three colors, color to swap 0, 1, and 2, they're the actual base colors. Let me see if I can pull up a picture of Huey here. Icon, logo, sprite editor, right? So these colors match color to swap 0, color to swap 1, and color to swap 2. Okay. So what I did was on the diamond skin material is I'm telling it to replace those three base colors with whatever color I want here. So the biggest color here, the main body color, is this light blue. So if I mess with this here, I can go ahead and change this to whatever I want. That's kind of cool, actually. I kind of like that black right there. Yeah, you can do any color here you want. That's pretty cool. Kind of crimson right there. And then I could change color to swap or not a new color here. So it's going to be the middle piece. You can make that like an orange or a yellow right there. Maybe, let's see what looks good with this. Yeah, I think an orange, maybe a lighter orange kind of. Anyway, just messing around here to show you what that looks like, okay? So it's going to look a little funny when I run because I didn't change the shadow color here. Let me do that real quick just as a demonstration. Pick the main color, bring it down in brightness here, and now we have a shadow for the limbs in the back when he's running, right? The back leg and the back arm. And now I've just turned our diamond skin into like a more crimson kind of color here. But I don't want that. So I'm going to go ahead and turn these back to normal. There's our diamond skin. Sweet. So this is how it's easily changeable within the Unity interface. It's really nice to work with. But let me show you how it works in the code actually. So we got the color swap shader here. And these, so if you've never seen shader language in Unity, it can be a little daunting at first. There's a lot of things that you have to learn that you don't typically see in a normal scripting experience in Unity. Once you get used to it, though, it starts to make a lot more sense. And I'll cover some of those things here. So this properties area here is where you can expose the properties that you want to be able to adjust within the Unity editor itself. So that was all the color stuff that I was changing here, right? Color swap 0, new color 0, and you can see that here. And this is where you put the name of what they're going to be called when they are exposing Unity. If I call this, I don't know, hot dog, I guess. Now, when I come back here, it says hot dog. Not a very descriptive name, not a good name. Definitely want descriptive variable names. Just an example. Okay, so these are the actual variable names. So when I go down, there's a few settings I had to set here to make them work, like making it transparency, making it compatible with transparency. And other stuff there. And then in the past, this is where we start actually doing the code that's going to do what I want in terms of changing the colors of the shade of the material and stuff. So here are all our variables once again that we exposed at the top. And what I'm doing here, so there's a couple different main functions within a shader that allow you to manipulate the material that you're using. And one of them is the vertex shader, which we're not really touching in this. We're not touching at all, actually. This would be how you could maybe contort and like change the vertices of your object. I wasn't really looking at that this time. What we are using here is the fragment shader. So the fragment shader is how you can change the colors of things. And we do that by the way the fragment shader works is it looks at every single pixel of your texture one at a time. And you can get the color value of each of those pixels here. This is the line that gives me that color value. So I say sample the texture 2D of the main text that we're passing in. So like in this example here, I think I have a better example. Materials, checkerboard. Do none of these have it? Okay, well, it's right here, the base texture. It's not showing anything right now, but when you attach it to a sprite, it inherits the texture from the sprite itself. So that's what main text is. And it uses i.uv. This is where it determines where in the texture to take that pixel color value from. So you might be wondering what this means. You may have heard of UV coordinates or not. But basically, this vertice object here, the structure, will give us the current UV coordinates. So UV coordinates is how shaders map out where a certain pixel is on a texture. And it's pretty straightforward on 2D once you start using it. It's a little confusing at first, but let me pull up an example. So the way it works here is that every texture is it's stuck on this like graph here of like a coordinate system, sorry, from 0 to 1. So the U is like the X, the V is the Y here. And your texture is mapped to these 0 to 1 coordinates. Basically, the reason it's 0 to 1 is because you can kind of think of 0 to 1 as like 0 to 100%. So you can just map values from 0 to 1 to any other value, right? Because like 0.5 would be 50%. So if like you had, I don't know, your texture size was 200, UV value of 0.5 would be 100, right? So it's easier to map that way. So what ends up happening is your and I have a picture of Hue as an example. Your texture gets basically sampled onto this UV coordinate system, and what it's doing is it's going through each pixel one at a time, and it's returning to me in the fragment function in the shader, return to me the value of any single pixel here. Whatever pixel I'm looking at, it'll return the value there. So if I had like a value of if I'm looking at like 0.5 UV, then it would probably return to me a value like right here, right at the center, right? A pixel right in the center. So what I'm doing in my fragment shader is I'm saying, looking at the UV, or get the color at the current UV, and what I want to do is if the distance between the color that is currently being read and one of the colors that I want to swap between 0, 1, and 2 is within a certain threshold, it means it's the difference between the colors is so small that they're probably equivalent, that they are equivalent in this case, then swap that color that we're going to return at the end of the fragment shader. This color that is returned is the color that is set within the material. When I'm doing this, I'm saying swap the original color with the new color that I want to swap, right? So I'm mapping these color swap 0 to new color 0, color swap 0, 1 to new color 0, 1, and so on, right? So I'm saying take the difference and now let me explain the distance function here too. And so the reason I'm doing distance here, if you notice float 4 is the type of thing that a color is. It's the type of object it is. And what that is essentially a vector with 4 components. And that's red, green, blue, and alpha. Now because those are float values, you can treat them as just any other vector. So let me see if I can show that here. Let me open a new layer and I guess I don't have to get rid of Huey here. Let me get rid of that thing I drew though. So what I'm saying is if I had a vector to 0.5, 0.5, right? So there's a vector here, and let me see if I can switch to brush mode. So this is my vector. It looks a little soft there. But this will be a vector of a U component of 0.5. Actually, let me change this brush. Let's make it harder. Yep. Sorry about that. 0.5. So that's the U component. It goes across. And the Y and the V component is also 0.5. So this coordinate value of 0.5, 0.5 can be represented as a vector. But it's the same thing with the color. Let me see if I can actually pull up a picture of that. Yeah, so if I look at this here, this color dialog box, we could do something very similar here where we drop a vector, and this is not exactly how it works with RGB, but just to give you an idea, we could draw a vector to a green point here, like where this cursor is. You could draw a straight line there. And actually, let me do this with the snipping tool so I can illustrate it better. So what I could do is, let's go with black. I can represent this color value as a vector. And what I'll say is when I'm looking through that shader, when I'm looking at the pixel's colors, I can say if the pixel I'm currently looking at, if this is the target color, if the second vector, sorry, not the second vector, if the vector I'm looking at matches the color that I want to swap with, if the current pixel color from the texture, okay, so like if the color right here at Huey is close enough that if I subtract those vectors, if I had another vector that was like pretty much the same right here, running parallel to it, let me change the color of that. Let's go with the purple here. If I had another vector that was pretty much running parallel to it, and the difference is so minuscule, right, on the color spectrum, then I know to replace that color. Okay, let's move on from that. Hopefully that was a clear enough explanation. If you know about vectors, then this will make a lot more sense. If you don't, hopefully I give you an idea here, a little bit of an idea. Vector is a line with a magnitude and direction. And so if you have any two values, they can be represented as a vector. So we're just saying if the difference is so small that they're pretty much equivalent, then I know I'm seeing the color that I want to swap. And let's swap. Okay, so that's the color swap skin. Now let me go into the checkerboard material. Okay, so let me go ahead and set the checkerboard to active. Continue. And let me run Huey into the center here and zoom in. So for this checkerboard skin here, what I did was I used those UV coordinates and I just basically treated them as any other coordinates, and I broke them up into a checkerboard pattern. The way I did this was I used a modulus value. I used the modulus operator to check the value of my current UV position and determine whether that should be black or white. So if I go to the checkerboard, it also has color to swap here. It has the colors to swap, and is this the newest version of it? This is not. This is the newest version. It has the colors to swap, and what I say is find those colors, swap them with the white or black. Right? Checker like color light, checker color dark. And once again, just like with the other skin, with the other material, I can change this to whatever I want here. Right? If I like green, I can set this to green. Now Huey's got a green and white checkerboard. Or this, what will look good with green? Something across the spectrum, right? Complementary colors, something like that. Hey, almost looks a little Scottish now. But anyway, let's go ahead and change that back. So what we've got going on here is, once again, swapping the colors I want with just 2 colors this time. I'm not looking at specific colors and swapping them out with other specific colors. I'm just building a pattern of black and white and swapping all 3 colors if that's possible. And we also expose values for the checker size. I can control the checker size here if I want these to be a lot bigger, or I want them smaller, small enough and he's just all white. Looks kind of cool. Bring this back. And then height correction scaler. I had to add a little bit of a correction scaler here because the checkers were looking a little funny, a little too rectangular. Let me just change those values back to what they were before. And let's go into the code for that. The checkerboard shader. Here you can see where I expose all those properties in Unity once again. And here we have the actual code for it. Let me zoom in a little more here. I hope the last code was a little more legible. Was legible at least. So here we go. Here's the fragment shader again for the checkerboard material now. So once again, I'm doing that distance check, but I'm actually sticking all 3 of those colors and I'm going to swap into the same Boolean check here, into the same if statement, because I don't really care which specific one it is. They're all going to be replaced. And the only thing that determines which color is replacing them is the checkerboard pattern. And what I'm doing here is I have my checker size. That's what I showed you in the Unity parameter there in the inspector. And what I'm doing is I'm taking the modulus of that, here, I'm taking the sum of the UV coordinates. So what I'm taking is, so UV sum can potentially be a sum. Sometimes it's just the U coordinate. I'm basing it off the U and V coordinates. So what I'm doing here with the checkerboard pattern is you'll notice that they have to be offset. Every other row will start with black, white, black, white, black, white. So it changes. The pattern changes there. And so what's happening is the way I determine when a checker changes to the other color is I take the checker size, okay, I do the UV value right there. So first by default, I'm only looking at the U value, which is the equivalent of the X. And I'm saying if the modulus of that by the checker size is less than checker size divided by 2. So let's say I wanted my checker size to be a value of 40, okay? If I want my checker size to be a value of 40, what this is saying is I'm cutting that 40 into half. So the first 20 pixels will be black, the second will be white, or whatever pattern I choose, or white or black, black or white. And the way I do the offset is I say, if the V value here, I'm adding an offset, which by default is 0. If the V value, okay, maybe I should be drawing this out to illustrate better. So let's see if I can remove Huey here. Maybe I can remove all the drawings here too. Make a giant thing here, yep. And so what I can do here is nice. Okay, so I'll make a pattern real quick, get into it. So the checker size that was exposed that I showed you in the inspector there that I could change, that I could modify, is technically actually 2 checkers here, 2 checker patterns. So like, let's say I had a checker size of 40. The way I'm determining it is it's going to be black or white, depending on whether they fall into below half the checker or above half the checker, right? So this point here would be 20. So this would be a U value of 20 since we're going across here with the U value. So what I'm saying is if you're not familiar with the modulus operator, essentially what happens is if you divide something by a modulus amount, if you divide something using modulus, it returns the remainder, okay? So it does integer division, and what happens is you're going to get repeating values from 0 to the number you're dividing by. So as an example here, let's say I took 20 divided by 40, okay? That would be the halfway point that I illustrated here. 20 divided by 40. 40 does not go into 20, right? It doesn't fit. So that would be 0, remainder 20. Because you have the whole 20 left over. You were not able to divide 20 by 40 using integer division, meaning no decimals allowed. Okay, so that's when that threshold changes. In my logic, what I'm checking is here, if I take that UV sum, which is the view value potentially added with an offset from the V, depending on whether I want there to be a swap in the beginning checker color value. If I take that value and I do the modulus division by checker size, if that is less than the checker size divided by 2, right? Less than this value here, then it's going to be equal to the dark color. If it's greater than or equal to that, greater than or equal to checker size divided by 2, then else it will do the light color here. So just as an example, another example here. So if I did 41, let's say this position here, right here, this might be a value of 41, okay? And just to illustrate this modulus math one more time. So if I did 41 divided by 40 here, this would go into 1 time, but there would be a remainder of 1. Oops, that's an R. Remainder of 1, okay? So what happens is those remainder values loop back and forth. Every time I add a new number here, so before I could go into 0 times, right? Once I reach 40, I can go into once. Once, let's say I got into 80, right? If I was at the pixel coordinate of 80, then I could go into it twice. Every time this number goes up by 1, these remainder values reset. So it's going to go 0 to 39, reset, 0 to 39, reset. So using these kind of modulus remainder values, I can determine whether I want my checkerboard value to be black or white, and whether I want them to swap the pattern here where it starts with black here, then starts with white, black, and then white, right? And the line that determines that, where I calculate the offset here, is I'm doing a very similar modulus check. If the height correction scalar, you can kind of ignore that. Basically, if the V value, okay, essentially the height, the Y value, times, if that divided by the checker size, modded by 2, okay, so if that is equal to 0, then we set the offset to checker size divided by 2, which ends up affecting this here. It ends up throwing that view value ahead by half a checker size for that entire row, right? So what it's saying is essentially, even though my U value might be here at 0 position, that offset is saying, no, technically, I want you to map it to this position here for the rest of the row. So it actually kind of seems to like extend past the checkerboard at some point. That might be a little hard to visualize, but that's essentially what it's saying is, move past by 1 checker size. And let me just explain this again really quickly. Basically what's happening is I'm taking the floor, which is removing any decimals from this division I'm doing in here, and I'm taking a modulus of 2. What I'm saying here is if it's an even numbered row, modulus of 2 remainder equals 0, that means it's divisible by 2, the number of the row, then we will set the checker size, the offset to checker size divided by 2. Otherwise, offset remains 0 as it was before, and that's how we now get that swapping black and white for the start of the rows. So that's pretty much it for the shaders that I wanted to cover today. I hope you got a good overview of that. I'm hoping to do more awesome stuff with shaders in the future and hopefully cover it on these videos, on these devlogs. So I think we are about ready to wrap it up. So overall, I want to say that I'm super happy with the feedback we've gotten for Gravitorium so far on the demo. It's been really awesome. People are really enjoying it. There are some people who are really determined to bump their scores up on the leaderboard. There's a few people here who have like really been grinding, and it's like this #1 spot person. They've increased their score several times. So is this person here, etc. It's so awesome to see. It's very satisfying. I was really hoping the time trial would be a motivator for people to come back. And I personally love watching speedruns. I love playing games pretty quickly and technically. So it's really nice to see that a feature I added that is supposed to cater to that kind of crowd is actually doing what it's supposed to. I'm just waiting for that first person to break that 3-minute barrier. That's not me. And I guess one last thing, you can actually play our game on itch.io now as well. Let me see. So that would be if you go to itch.io and you search up Gravitorium, it'll be the third option here, and you can run it in the browser. So first things first, let me make sure the volume's down here. So this is basically the same exact demo that's available on Steam. It runs great on here. It's got all the skins, the updates. This one's slightly behind. It doesn't have the new control hints, but otherwise it's got everything available. And as you can see, I actually unlocked the diamond skin here. Because this isn't connected to Steam, I didn't mind setting a new high score here. So I've got a sub 3 minutes time here. So it is possible. So just so you know, it is possible. I'm not trying to cheat people out and make them grind to some crazy goal that doesn't exist. Anyway, so yeah, completely playable here if you don't have access to Steam or you just prefer picking it up on the browser. This does also save your progress, just like it does on Steam. I've got all my settings saved here. The only thing is if I push new updates, it will unfortunately remove your progress because I have to replace the entire web build. It's really unfortunate, but there's no real way around it right now. I may potentially just keep the build like this or update it one last time to have those new control hints for the movement. But otherwise, yeah, I'll probably just keep it similar to where it is now, so I don't have to constantly update it. Anyway, so that's Gravitorium for now, the demo. Like I said, it's been going great. Having a lot of fun working on it. Been super motivated lately with all the great feedback. I hope more people check it out. I hope you enjoyed this devlog. Please leave your feedback below. Please play the game and wishlist it. We have worked super hard on it. We appreciate all the support we can get. Go play, get on those leaderboards. See you next time.